Now let's find M resultant. How to find M resultant? Basically, M resultant will be equal to the sum of all the moment of these forces around O. Now here I don't have any external moment because in fact I don't have any couple of forces, so I can say that M resultant that is equal to the sum of all the moments is equal to the moment of F1 around O plus the moment of F2 around O plus the moment of F3 around O. And let's start, guys. Now here in this case, since this is a 2D case, I will be using the method that we have proved. I don't remember in which video, but it is it is defined by this equation. M is equal to Fy, the component of the force in y direction, times x minus Fx times y. And don't forget, guys, that in this method, the moment will be given in plus k or in counterclockwise direction. So it is this. Okay, so basically, guys, this method will give me a moment in plus k or in counterclockwise direction. So did you see? This is the counterclockwise direction. And remember, guys, that Fy, Fx, x and y are all scalar values, so they could be negative. And remember that Fy, Fx are the components of the forces of the force in x and y directions, while x and y are the coordinates of the point of application of this force. So I will start by M1. What is M1? Basically, it is F1y, that is a 3 sine 30 times x. Now what is x here? So x here is basically equal to 0.2 minus fx, that is 3 cosine 30 times y, and y here is from this point to O, this is 0.1. So this is M1. Let's go to M2. M2 here has a negative y, so it is minus F2y, that is equal to 5/4 over 5 times what? Times x, and x here is 0.5 in plus direction, so this is x, it is 0.5. Minus fx. Now here fx is positive and it is equal to 5/3 over 5. However, y is negative, guys. Y is negative, okay? So this is y of f2. So this is the point of application of f2. Y is under O, okay? So it is times minus 0.1. And what is M3? M3 is basically here I don't have x component, so it is only y. So basically it is minus 4 because Fy is negative, while x is positive, that is equal to 0.2. So this is M3. And now I can find M resultant. M resultant will be equal to 3 times 0.2 times sine 30 minus 3 times 0.1 times cosine 30. So I'm adding them together and so on. Okay, so now the answer is minus 2.46, and the unit is kilonewton meter because basically, as you can see, the force is in kilonewton and all the dimensions are on meter. So since this answer is negative, this means that M resultant is not in counterclockwise, it is basically in clockwise direction or in minus k direction. So this is M resultant, and now I can draw it on my figure. Okay, so let's draw it on our figure. So as we said, this will be F resultant. Okay. This is the angle theta, that is almost equal to 50. And M resultant will be in clockwise. Since now, guys, I modify its direction, I cannot say that it is equal to minus 2.46. No, now M is equal to 2.46 kilonewton meter. So this is basically the simplification of the force of all the forces and moments that exist in this force system. So I can remove all of them and I can put this force and this M resultant on point O. This will have the same effect on point O in translation and in rotation. Now guys, if I move to the second problem, so here what do I have? I have a 3D system. So as you can see, I have now a 3D system. I have two forces, F1 and F2, and I have an external moment vector M. So of course, guys, since this is a 3D case, I should apply the 3D method, which is based on the cross product or the vectorial method. So the question is the same as the previous one. It is to find the resultant force and the resultant moment around O. Basically, guys, I will not solve this in details, but I will give you all the steps so you can solve it by yourself. It is very easy since the vectorial method, if you know how to do it, you can find the answer without worrying about the sign and the direction. So the steps is basically to find F resultant and M resultant, and in order to find F resultant, I should go over the steps in chapter 1 and 2, which is to find F1 and F2 in vector form. Now here F1 is obviously in minus Z, so it is minus 800k. This is F1 in vector form. F2 is basically in a plane that is parallel to the plane xy, and in order to find F2 I should find the unit vector CB, and as you can see here I know the coordinates of CB, so this is option 3 in chapter 1 and 2, so I know the coordinates of C and B, so what I should do is to find F2 using these coordinates or using the unit vector CB and not BC, because F2 is going from C to B, or it has the same direction of CB. So basically F2 will be equal to 300, the unit vector of BC. And don't forget, guys, that in order to find this unit vector, I should find the coordinates of, the unit vector of CB. Okay, so as I said, it is from C to B, where C is what? C lies on the Z axis, so basically it has 0, 0, while Z is 1. Now B has the same Z as C, so of course B has a Z also of 1. However, B has an X of minus 0.15 because it is in the opposite side of the positive X, a positive Y of 0.1, and the same Z of C that is equal to 1, so I can find the vector CB, and from this vector I can find UCB. So now I know F1 and F2 in vector form, so I can find F resultant, which is F1 plus F2. Am I done here? Of course not, because this is the only first component of the equivalent resultant system. I should also find M resultant. Now here, guys, since this is a 3D, I should find this M resultant using the vectorial method, but don't forget that I have an external moment here that is equal to 500 Newton. So basically my M resultant will be equal to what? M1, I mean by M1 the moment of the force F1, M2 that is the moment of the force M2, and M in vector form. Okay, so let's find M1. M1 is basically R1 cross F1. Now what is R1? R1 is from this point of rotation that is O to any point on the line of direction of F2. So here, guys, you can pick B. I will pick C because it is very easy to find OC since C lies on what? On Z. So I will pick C. So basically R1 will be OC, that is basically equal to 1K cross F1. Of course F1, I know it because I have found F1 in vector form. Now what is M2? M2 is, this is M2, guys, okay? It is also applied to F1, so I can also find M2, so I will repeat, M1 will be for F1 and C belongs to F1 also, okay, so I can say it is OC cross F1, C belongs also to F2 because it belongs to the line of direction of F2, so I can also say it is R2 cross F2, which is also OC cross F2, and finally I should find M in vector form. Now what is M in vector form? M is basically this 500 Newton. What? 500 times what? In fact, guys, if I go over this m, it lies in the plane what? In the plane z minus y, so it will have only two components, one in minus y and minus j, and the second one in k. So basically, guys, m will be equal to 504 over 5j, and this is in negative, and it is in positive z, 503 over 5k. So this is m. You can now find m1, m2, and m, sum them together, and I will put the solution right now so you can find m resultant, f resultant, and then you can put them on O. Thank you.